Welcome all. Today we are going to see that the concepts of measurements. Myself, Dr. J. Radhalakshmi, Assistant Professor, Department of Electrical and Electronics Engineering, SRM Madurai College for Engineering and Technology. The concept of measurements includes the measurements and instrumentation, errors in measurements, calibration, as well as the standards. First, the measurement is meant by comparison between a standard and what we measure, that is called the measurand. The two quantities that are going to compare, the result is expressed in terms of numerical values. The basic requirements for a meaningful measurement is the standard. So the standard used for the comparison purposes must be accurately defined and should be commonly accepted. The apparatus used and the method adopted must be provable or verifiable. The major functions for all branch of engineering while considering the measurement processes is design of equipment and processes and proper operation and maintenance of equipment and process. The method of measurements are divided into two types. One is direct methods, another one is indirect methods. In the direct methods, the unknown quantity called the measurand is directly compared against a standard. But in the indirect method, measurements by direct methods are not always possible, feasible and practicable. In our engineering applications, measurement systems are used which require need of indirect method for measurement purposes. Instrumentation and measurement systems which involve the use of instrument as a physical mean of determining quantities or variables. In any branch of engineering, any quantities, we need the measurements in terms of determining the quantities as well as the variables. Because of modular nature of the elements within it, it is common to refer the measuring instrument as a measurement system. The evaluation instruments, which includes mechanical, electrical, electronic as well as instruments. The mechanical instruments are very reliable for static and stable conditions, but their disadvantage is that they are unable to respond rapidly to measurements of dynamic and transient conditions. While considering electrical instruments, it is faster than mechanical, indicating the output, or rapid than mechanical methods. But it depends on the mechanical movement of the meters. The response is 0.5 to 24 seconds. While considering the electronic equipments, it is electronic measurements, it is more reliable than other system. It uses semiconductor devices and weak signal can also be detected. Let us see the classification of the instruments. The major classification are absolute instruments as well as secondary instruments. The absolute instruments, these instruments give the magnitude if the quantity under measurements terms of physical constant of the measurement instrument. The secondary instruments are calibrated by the comparison with absolute instruments which have already been calibrated. It is classified into, the instruments are classified into deflection type instruments as well as null type instruments. The functions of instrument measuring system can be classified into three. They are indicating function, recording function and controlling function. The application of measurement system are monitoring of processes and operation, control of processes and operation and experimental engineering analysis. Elements of generalized measurement system, that is the functional element of the system, which includes primary sensing element, variable conversion element and data presentation element. These are the functional element of the system. So first one is primary sensing element. The quantity under measurements makes its first contact with primary sensing element of a measurement system. And next is variable conversion element. It converts the output of the primary sensing element into a suitable form to preserve the information content of the original signal. The last part of the functional element system, that is data presentation element, the information about the quantity under measurement has to be conveyed to the personal handling the instrument or the system for monitoring, control or for analysis purposes. So this is the functional element of the instrumentation system. So as we study that the primary sensing element, variable conversion element, and last one is the data presentation element, that is manipulation as well as the data transmission element included. So these are classified as, the initial stage is mentioned as detector transducer stage, and the variable conversion and variable manipulation is data conditioning element, that is called as intermediate stage, and final stage is the terminating stage, that is the data presentation element. So these are all the functional element of the instrumentation system. Next we will see that the characteristics of instrument and measurement system. First one is the static characteristics of instrument and measurement system. The application involved measurement of quantity. They are either constant or vary slowly with time is known as static. So the various characteristics involved are accuracy, drift, dead zone, static error, sensitivity, reproducibility, static correction, scale range, scale span, noise, dead time, hysteresis, and linearity. These are all the static characteristics. While considering the accuracy, that is nothing but this, it is the closeness with an instrument reading approaches the true value of the quantity being measured. Next is the true value, that is the true value of the quantity may be defined as the average of an infinite number of measured value. Sensitivity is defined as the ratio of magnitude of the output response to the input response. Reproducibility is specified in terms of scale readings over a given period of time. Next, the drift. Drift is an undesirable quality in industrial instruments because it is rarely apparent and cannot be maintained. So it is classified as zero drift, span drift or sensitivity drift, and last one is zonal drift. Previously we have studied the static characteristic of measurement systems. Next we will see the dynamic characteristics of measurement system, which includes speed of response, the measuring lag, fidelity, and dynamic error. So these four are the dynamic characteristics of a measurement system. So speed of response. The speed of response defined as the rapidity with which a measurement system responds to changes in measured quantity. It is one of the dynamic characteristics of the measurement system. Next is fidelity. It is defined as the degree to which a measurement system indicates changes in the measured quantity without any dynamic error. The dynamic error, it is the difference between the true value of the quantity changing in time and the value indicated by the measurement system if no static error is assumed. It is also called measurement error. It is one of the dynamic characteristics of the measurement system. The next important characteristic is measuring lag. That is nothing but the retardation delay is the response of a measurement system to changes in the measured quantity. It is of two types. One is retardation type, another one is time delay. The response begins immediately after a change in the measured quantity has occurred is called the retardation type. The time delay is nothing but the delay occurs in the response. The response of the measured system begins after dead zone after the application of the input. Next, we will see the errors in measurements. So, various errors we have considered in the measurement systems. Here, the limiting errors, that is the guarantee errors, known error. Classification can be considered as gross error and systematic or cumulative error, random or residual or accidental error, and the systematic cumulative error classified as instrumental, environmental as well as observational. So gross error, so we know that the human mistakes in reading, recording as well as calculating the measurement results considered as a gross error. The experimenter may grossly misread the scale because for example, due to oversight, instead of 21.5 degrees Celsius, they may read as 31.5 degrees Celsius. They may transpose the reading while recording. that is like recording for 25.8 degrees Celsius, they may record 28.5 degrees Celsius. This can be considered as a gross error. Next is systematic error. So systematic error is instrumental error. These errors arise due to three reasons: due to inherent shortcomings in the instrument, due to misuse of the instrument, due to loading effect of the instrument. So environmental error, these errors are due to the conditions external to the measuring device. They may be pressure, humidity, temperature, or external electrostatic or magnetic field. The observational error, so the error on account of parallax error, that is called the observational error. And the residual error, so these errors are due to multitude of small factor which change or fluctuate from one measurement to another measurement. The happenings or disturbances about which we are unaware or lumped together are called random or residual. Hence, the errors caused by these are called random or residual error. The various factors we have to find out from these factors are arithmetic mean, variance, as well as the standard deviation. So we know that the arithmetic mean is the average of the reading samples or divided by the total number. So we will see that the arithmetic mean is the most probable value of measured variable is the arithmetic mean of the number of readings taken. So it is given as x bar, that is called the arithmetic mean. So which is nothing but the x1, x2, x3 up to xn, that is the reading samples divided by xn divided by n is the number of readings. So sigma x divided by n is considered as the arithmetic mean. So next is deviation. Deviation is the departure of observed reading that is taken from the arithmetic mean of the group of readings. So up to the deviation may be calculated for each and every sample. So d1 is nothing but x1 minus x bar, that is x bar is arithmetic mean. d2 is x2 minus x bar. Similarly dn is xn minus x bar. So the summation of all the deviations is equal to 0. Next is the standard deviation. This is also the important factor. So the standard deviation of the infinite number of data is defined as a square root of the sum of the individual deviation squared divided by the number of readings. Standard deviation sigma, that is nothing but square root of d1 square plus d2 square plus d3 square up to dn square divided by n, that is sigma d square by n, that is greater than 20 observations. While considering for less than 20 observation means the deviation, that is root of d1 square up to dn square divided by n minus 1. Next is variance. So variance is square of standard deviation, that is sigma square. Similarly, for greater than observation is divided by n. For less than observation, this is n minus 1. The calibration, this is an important standard while considering for the measurement as well as the instrumentation. This is calibration of all instrument is important since it affords the opportunity to check the instrument against a known standard and subsequently to find errors and accuracy. The calibration procedure involve a comparison of the particular instrument with either a primary standard or secondary standard or an instrument of known accuracy. Secondary standard, which is nothing but with a higher accuracy than the instrument to be calibrated. The standard. So standard is a physical representation of unit of instrument. So the standard is applied to a piece of equipment having a known measure of physical quantity. So the type of standards includes international standards that should be defined based on international agreement, and primary standards maintained by the national standard laboratories, and secondary standards used by industrial measurement laboratories, and working standards used in general laboratory. So these are all the basic concepts we have to know about the measurement as well as the instrumentation. So we have considered all the factors as well as the classification and as well as the errors, everything. So this is the basic concepts of measurements as well as the instrumentation. Thank you. We will see in the next class.